Hi everyone, this is Saad Aslam and welcome back to the channel. I hope you are all doing well. Today we are going to discuss another LeetCode question in our comparative programming series. The question is like we have to find a cycle in linked list. Before moving on, let's first discuss the problem statement. You are given a head, the head of a linked list, and you have to determine if the linked list has a cycle in it. Okay, so there is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. Internally, POS is used to denote the index of the node that tail's next pointer is connected to. Note that POS is not passed as a parameter. That is simple. You have to return true if there is a cycle in the linked list. Otherwise, you have to return false. This is like pretty straightforward question. And before moving on, if you haven't subscribed to my channel, make sure to hit the bell icon and all of the YouTube stuff. Let's first try to understand this problem and the approach of it in our whiteboard section. We will take the example 1 as in our whiteboard section for the reference. Let's go to our whiteboard section. Okay, so here we are in our whiteboard section. So let's try to understand what a cycle is. Okay, so in the first example, let me just take the pointer. Okay, so in the first example, here you can see the last node, that is 5, is pointing again to the head. So there is a cycle in it. So this is a basic example of cycle. And in the second example, here you can see there is no node that is again pointing to any node in the list. So there is no cycle. So in that case, we have to return false. And in the third example, that is the question they are asking in the LeetCode problem, is like the node is pointing to any further node, like 5 is pointing to 3, so there is a cycle in it. Okay, so in that case we have to return false or return true, there is a cycle in it. So the naive approach, they are like first discuss the naive approach, and then we will further on move to the more optimal solution. So what we can do is like we can take a hash set, like suppose we have taken a hash set, and we can keep on adding the elements in the set. Whenever we find any new node, we add it in the hash set, and if we find it again, like whenever moving to the list, whenever we find that node again, we can find out that the node has traversed again. So in that case we can return true. So in that case we have to add the whole node, not just the value, because there can be any cases like there can be duplicate values. Suppose in the start there is 3 and in any further nodes there is 3. So we have to differentiate what is the node that it is the first node or is the further node. So for that case we have to add the whole node in the hash set. Suppose we are adding 1, okay, and second will be 2, okay, and 3 will be second, like this will be 3 added in the hash set, and 4, okay, and 5, and when it goes to 5, it will go to 3 and it will check in the hash set as 3 is already present. Okay, so it can return true because it is already present in the hash set. But the problem here is the time complexity of this will be of, you can say, n, but the space complexity will be also order of n, because we are using another data structure, like we are using hash set for it, for storing the elements. So this is the naive approach. So let's try to understand and make it more optimal. So let us move to the optimal solution. Okay, so this is the example that is given in the LeetCode. Like suppose, let me just, so this is the same example 1 that is provided in the LeetCode. So let's try to find out how we can move on to the more optimal solution. So what we can do, okay, so what we can do is like we can make two pointers, like suppose one can be a fast pointer, okay, fast pointer, and one will be the slow pointer. So fast pointer will move two nodes to the, you can say, forward, and slow pointer will move one node forward. Okay, so suppose both f and s are initially at 3. So the next iteration, let me just make some space. Okay, so for the next iteration, s will move here and f will move here. Okay, so now our s is at second node and f is at third node. And for the next iteration, what we'll do, like f is moving 2 points, so first it will move here and the second it will move here. Okay, so after moving 2 points forward, f will move to here, because there is the next of this 4 is pointing to 2, and s will move 1 point as this. Okay, so after the next iteration, what we'll do, like s will move 1 point forward and it will go here, and as f will move 2 points forward, so where it will reach to the node 4. Okay, so there is a point we have find out when both fast pointer and the slow pointer are colliding, like they are at the same point node. So we have to find, in any case, towards the, you can say, traversal of the linked list, in any case both the fast and slow pointer are colliding, so it means there is a cycle in the list. Okay, so this is the approach, and the time complexity is order of n, but the space complexity of this is order of 1, because we are not using any extra space for it. Okay, we are just using pointers. So this is the more optimal solution, and we are going to implement this in our coding section. So I hope you understand the approach. So let's try to implement this in our coding section. So let's go to our coding section. Okay, so here we are in our coding section. So as I have discussed, we are going to implement this in both Java and C++. First we are going to implement this in Java, and after that we are going to quickly implement that same code in C++. So first of all, what we need to do is, like, if the head of the linked list is null, or the next of the head is null, we are simply going to return false, because there is no further, you can say, list, there is no cycle in the list. Okay, so if head is, you can say, null, or the head dot next is equals to null, so what we are going to do, we are going to return false. Okay, so after that we are going to initiate, this is a, like, you can say, first of all we are validating if the head is not null. If it is null, we don't have to go further on or do all of the processing, we can just simply return false from here. After that we are going to initialize two pointers, that is the fast pointer and the slow pointer. We can name it as fast ptr, and list node it is slow and ptr. Okay, and list node fast pointer, slow pointer, and fast pointer. Okay, so now we are going to move through a loop like that, it will traverse the list, and after, if we didn't find any cycle in the list in the loop, we are going to return false. Okay, so let's implement our main logic in our while loop. So what we'll do, like first pointer node is equals to null, like it will move until the next of the fast pointer is not null, or if the next fast pointer dot next node equals to null, like if the last element the next of the last element is not null, or if the second last element dot next is not null, that then this loop will continue. Okay, and first pointer dot next node equals to null. Okay, so the loop will move until these conditions are not met. So fast pointer, as we have discussed, it will move 2 points forward. So fast pointer dot next. Okay, and slow pointer will move slow ptr dot next. Okay, slow ptr dot next. Okay, slow ptr. Okay. So fast pointer will move 2 points forward and slow pointer will move 1 point forward. And throughout this traversal, if there is any collision between them, like fast pointer equals to the slow pointer that we have discussed in the example, we have to return false, return true, that there will be a cycle in the list. So fast pointer is equals to slow pointer, then we are going to return true. Okay, so this is the logic, main logic. So let's quickly go through any grammatical errors or syntax errors. If head is null, head dot next is equals to null, return false. Pointer is not pointer, not equals to null, not equal fast pointer and dot next and next. Return false. Okay, so let's try to run this code. Okay, so there is an error. Fast pointer might not have been initialized. Okay, oh sorry, what we have so where, like we haven't you can say, let me just, where we have missed one thing, like we haven't initialized the pointers to the head, like because the fast pointer and the slow pointer will start moving from the head, so we have to initialize them to head, both of them. Okay, so is equals to head. Okay, so let's now again try to submit this, sorry, run this code. Okay, so here you can see code has been like run successfully. Now let's try to submit this. Okay, so the code has been submitted successfully. I hope you understand the code and implementation of it. So let's try to quickly implement this in C++. Okay, so the approach is same, just the implementation in C++. So quickly go through the implementation of it. Okay, so the code has been submitted successfully. So now let's to submit this. So here you can see we have done the implementation in both C++ and Java. I hope you understand the problem statement and the implementation of it. If you have any queries regarding this question, you can let me know in comments. You can reach me out on LinkedIn. I have a proper course I have started regarding this course. You can, if you want to know more about this course, you can reach out me on LinkedIn. So I hope you are going all through all of these videos. So see you in the next video. Bye bye.